Hey there. Good evening good evening, good day, good afternoon, good morning to all of you. Fantastic to see so many people here today with us. So far, we have 45 fellows here with us on the call. Very great to see you all. By a show of hands, where do you guys call us from today? Let us know in the chat. It's always interesting to see where people join us from for these kind of events. So, yeah, where are you based? Where are you joining us from today? We have somebody from Mexico. Oh, fantastic. We have someone from Florida, Malcolm from Gibraltar, Palash from New York. Wow, Zanzibar. First time I have somebody from Zanzibar. Buenos Aires, Argentina. Hello from the UK, Gomati. I'm from Indonesia, India, and there's someone from London. Oh, that's fantastic. Yogesh from India. We have Surarish, I hope I pronounced that correctly, from Calcutta. Nice. We have Indiana Jones from Argentina. Hey, Kenneth from Singapore. Hey, I'm also calling from Singapore. How are you, Kenneth? And nice. Well, that's cool. Okay. We have someone from Malta. Wow, that's nice. Someone from Malaysia. Hey, Mohammed. Mohammed. And yeah, so some people from our past workshops also join us today, which is great. Okay. So everyone who will start in about a minute or two, just waiting for a few latecomers to join us. And Alan Shaw from IPFS Filecoin is already here with me, and he will take over then and guide you through the session today. Unlike the other two tracks, last week, the workshops, this track is particularly interesting for everybody who's working in the NFT Vision Hack, because you can literally use IPFS and Filecoin technologies for all the stuff you do around NFTs. So it's not just for the gaming and NFT track, which is obviously the main track, and we're also going to talk about that today. But it's really something you can use, for everything you do with NFTs if you develop stuff around NFTs. So yeah, really looking forward to this workshop today myself, and can't wait to get started. So yeah, just give it another minute or so, and then we should be ready to go. So yeah, fantastic show up. 57 people right now in the room, and yeah, Ellen, are you able to unmute yourself, or should I help you? Let me know.
Yeah.
Nice. So how are you today? How are you this afternoon, Ellen?
Perfect. Can't wait to get going.
And wait to get going. Great. And you're calling us from London. That's correct, right?
I'm in London in my baby's bedroom, because that is the arrangement that I have for working right now. So.
Oh, fantastic.
That's why I've got a blurry background, so you don't just see all of the stuff in here.
So will we hear the baby today?
Maybe.
Maybe. Okay. It's
Hopefully not. Hopefully not.
Let's see. Yeah, hopefully not. No, I think should be all right. I think in our previous call there wasn't no baby to hear. Yeah, I think people still joining, but I think anyway, you probably start slowly, right, and then you get into the gist of things. And yeah, why don't you take it ahead, Ellen?
Sure, thank you. All right, here we go. Okay. Say something if you don't see my screen.
Yes.
Okay, got to switch it up a little bit. So hi, I'm Alan, and here we go. There we go. I'm an engineer at Protocol Labs. Yes, the logo looks a little bit like a heart because it's such a lovely place to work. And at Protocol, we're building the next generation of the internet. So no big thing. But what are we really building? Well, IPFS and Filecoin are the two biggest focuses at PL, but both of those kind of build on top of the other projects that are listed here, or most of them at least. And Filecoin is actually kind of built on top of IPFS technology, so it should really be kind of on top in this diagram, but it doesn't have space, so it's side by side at the moment. So what is IPFS? Well, IPFS, in case you don't know, is a peer-to-peer distributed file system. It addresses files based on their content, not their location. And Filecoin basically adds the incentive layer to IPFS, and it's a cryptocurrency-based decentralized storage network. libp2p, it's a little colored square one there. That adds the peer-to-peer aspects of the stack. Testground is our platform for testing peer-to-peer systems at scale. So that's pretty vital. IPLD, interplanetary linked data. This kind of thing defines data structures and how they link together. And multi-formats is the thing that kind of ties a lot of this together. It's kind of at the bottom, the base layer of everything, and it's essentially formats that are self-describing and future-proof. So let's take a real quick look. Here we go. So libp2p, for example, uses multi-adders for peer addresses. Multi-adder is a multi-format for specifying network addresses. So if you ever look at one, then it's a really simple format. It's kind of like name value, name value, name value. But you can see here that we're specifying, like, we've got an IPv4 address, a UDP port, we're using the QUIC protocol, peer-to-peer peer ID comes next. So that's the kind of thing that multi-adders is about, or multi-formats are about. Another example is CIDs, and they are used by IPFS and IPLD to address data. CID stands for content identifier, and part of CIDs are multi-hashes, and multi-hashes are a self-describing cryptographic hash. So anyway, I'm not going to dive too, I know I've already gone too deep, but I'm not going to dive any deeper into this, but just the kind of take-home point here is that all these technologies are related and built on top of each other and work with each other. So yeah, that's basically it. SourceCred and Protoschool, they are slightly different. The SourceCred is kind of a tool to measure and reward open source contributions. Protoschool is a set of workshops for online learning of all of these technologies that are here. DRAND is awesome. It's a distributed randomness beacon. Essentially, we have nodes all over the world. The nodes are not controlled by Protocol in any way. That we run one DRAND node, but it's a distributed network of nodes that are generating randomness periodically. And it's used by Filecoin for stuff like leader elections. So DRAND is an awesome project. Distributed randomness. Cool, but this talk is about NFTs, the like off-chain side of them, and how they can be stored decentralized on IPFS and Filecoin for a long time. And so I'm kind of new to NFTs. I guess a lot of us are. NFTs haven't been around for a huge amount of time, but when I found out about them and started getting interested, I was really happy to see that IPFS was already being used to store them. So for instance, I can just go to like this. I found this cool game called the Sandbox, and it's got. Let me just.
I'm not sure I understand.
Hello. Okay. Thanks, Siri. So the Sandbox, it's kind of looks a little bit like Minecraft, but you can like create and trade elements from, or I guess assets from the game in like a marketplace. So you can look at any of these marketplaces on the NFT marketplace here. So like if I look at the Pirate Frog, which is probably my favorite, what I can do is I can just copy this token ID here, and the Sandbox actually uses a marketplace of marketplaces called OpenSea. So OpenSea, OpenSea. Here we go. That's the one. And so I can just paste that token ID on OpenSea, and I can see. I can hopefully bring up the Pirate Frog. Hooray! Okay, why is this important? Well, if we delve in a little bit more, we can see that the if I inspect this link here, the metadata, the thing that the information that the on-chain NFT links to is stored on, this is an IPFS hash stored in IPFS. So you can see that OpenSea at least are using IPFS, and that's super cool. And so NFTs are typically stored off-chain. They're actual big data files, because in Ethereum, at least, it's kind of prohibitive to store lots of data on-chain. So you typically store like this URL on-chain and then let people access it through IPFS if they want to actually get hold of the NFT. So here we go. Cool. All right. So as I learned a little bit more about NFTs, I came to realize that the developers that are actually enabling NFT creators, so people like OpenSea, Foundation, and Zora, these two are more like more arty based NFT traditional NFTs, I guess. Anyway, these people, they already cared about users being able to access their data should they ever just disappear. So if they just faded to black, then what they didn't want to happen was all of these NFTs and things that people have bought and owned to also just disappear, just like that. And so IPFS can solve this problem. It actually fits the bill really well. So it's not surprising to me that it's already being used. But if you're new to IPFS, let me just explain a few basics about how things work. Okay, so if you put data in an IPFS, so okay, I found this cool one-eyed squid thing that I'm going to use in all of the examples. But this is an NFT that you can buy, I think, from Sandbox. But basically, if you put data on an IPFS node, then firstly, what you get back is a CID, a content identifier. And that's that long string down the bottom there, the BAF, Ray, F46, et cetera. And CIDs, what they are is they're a kind of cryptographic hash, and they address the content, not its location. And it means that a given CID will always refer to the same piece of content. So to put it another way, if that content changed, then you'd have a different CID. A different CID for that content would have to be generated because it wouldn't refer to the same thing. So we typically store CIDs or like gateway URLs with CIDs in them on chain. But if we didn't store a CID on chain and used like a regular URL, like a Dropbox URL or like a Google Drive or something, or just a regular hosting account, generic hosting from somewhere, then that could be problematic for a couple of reasons. It could be at the end of that URL, the file could just be deleted by whoever owns that account, or the domain or the hosting could like expire. So that would be bad, and your NFT would just be gone forever, and that would not be good. Or they could, like, worst case, they could alter your CID. So my lovely picture of a squid with one eye could become like a rabbit or like a dog or something, which would not be what I paid the money for, which would not be great. And finally, like, that particular URL might just be inaccessible from where you are, like maybe in your country or your workplace, and you actually need a peer, on a peer-to-peer network who's close to you to deliver that content to you, because you can't actually get to the place where that centralized place where that content could be served from. So that's kind of cool. So how does this work? Well, if a IPFS node requests that data by its CID, then it essentially asks the network, and it says, does anyone have this content for this CID? And if someone on the network has it, then they'll answer and they'll receive it. That's cool. And now two nodes can serve the content. So, okay, rad. So a third node comes along and he says, who has this CID? And what's great is that both of these nodes can now help transfer the bytes to that node and serve and send him the file. Cool. Okay, now three nodes have it. And the awesome thing about this is that the original node that had the content can actually just go away. So they're gone. But the data will still be retrievable from the other two nodes who do have the content. And so this is the awesome power of peer-to-peer. Caveats. Caveats apply. Yes. Caveat one is that if if all of the nodes who have the content go away, then you won't be able to get the content because no one has it. It's rather obvious caveat, I'd say, but worth stating. If no one has it, you can't get it. That's just the fact of life. Caveat number 2 is a little bit more involved, but this caveat is garbage collection caveat. And so depending on your configuration, garbage collection may run at like a particular time. It might run when your configured repo storage limit is hit, like you've just accumulated enough data that the IPFS node has gone, okay, you're over the max, I'm going to do a GC run and get rid of all the trash. So it might do that. You don't know exactly when that will happen necessarily. Or it can be run manually. So you can actually, there's an API call, you can use it from the command line to IPFS repo GC, and it will do it for you. So, so garbage collection. Then if you garbage collect the thing that you were serving, then you won't have it anymore, so you can't serve it to anyone else. So you need to somehow tell IPFS that the content you have is not garbage. And the reason why you need to do this is because when you obtain content from the network that you didn't add yourself, that content is eligible for garbage collection. And so we need a way of telling our IPFS node that this content is a super rare NFT, not trash, please don't delete. And in IPFS, that's referred to as pinning. If you don't pin your data, then it will eventually be garbage collected. So even if this content is super popular and loads of people have it in the network, then it can eventually exit the network because people might not have pinned it, or they might have it and go offline and not care. And so these 2 caveats are why developers generally use a third-party service like Pinata, like Textile, like Fleek to store their NFT or any IPFS content, essentially, if they want it to always be publicly available. And the reason they do that is because these services have nodes that are publicly accessible. They stay online 24/7, and they also they pin the content so it doesn't get garbage collected. So yeah, that's why people use them. So that's that. How are we doing for time? Right, okay. NFT.storage. This is a thing that we've been working on. It's a place where you can store your NFT data. Ideally for this particular hack, your in-game NFTs, and it will be decentralized. It will be on IPFS and on Filecoin, and you can store it safe in the knowledge that it will be there tomorrow. And it hopefully goes some way to solving the permanence problem. And so, yes, it's free. It's free for as long as we can possibly make it free. And one of the founding ideas is that this should be really easy. Like this shouldn't be a difficult thing. So let's try that. Let's talk about how it works. So first of all, you've got your content. You upload it to nft.storage. Okay, pretty easy so far. And what nft.storage does is it will store that data on IPFS nodes. So there you have it. So far, so good. But what is different from a regular pinning service? Well, behind the scenes, nft.storage is negotiating deals to store data with miners on the Filecoin network. And so I've got 2 in the diagram here, but typically we'll try and get free deals with 3 separate miners at least, and possibly more. And so the Filecoin network, it incentivizes miners to store data. They get paid to store data. They also typically get paid when data is retrieved. They also get penalties if they stop storing the data before the deal term is complete. Then they'll get a penalty for that. So they're like pretty heavily incentivized to continue storing the data for you for as long as that deal is good. So anyway, why is it good that we're storing data on IPFS and Filecoin? Well, if nft.storage just goes away, like poof, poof, gone. Why is it gone? That's not good. If it goes away and then every other peer who ever fetched the content went away and nobody else is pinning it on IPFS at all, then the miners will still have the content. They'll still be there. And so what you can do is you can think of the miners as just another set of IPFS peers. We talked a little earlier about how Filecoin is built on IPFS technologies and everything that underpins IPFS. And they're essentially just another set of IPFS peers that have strong incentives to continue storing your data. And that's a pretty good level of redundancy, I'd say. So here it is again, nft.storage, free decentralized storage for NFTs on IPFS and Filecoin. We had a public launch a few months ago. The URL is nft.storage. Who knew .storage is a top level domain name? But it is. So there you go. You should take a look. And if you are going to be creating NFTs in your hacks for the hackathon, then you should store them on nft.storage, because that's what it's for. We have a really simple HTTP API. It's expressed as an open API schema. It means that there's like a formal specification for the API. It means we can generate like nice docs like this, where you can sit back and use the API from the comfort of your own browser. And so there's API docs. It's a really small and simple API. As you can see, there's only 4, 5. I can't even count. But yeah, so the API is super small, but actually, if you're going to be using it, you'll probably mostly use kind of 2 endpoints, I guess. So if you want to upload a file, then you just send a post to /upload. You want to check the status of like a CID that you've just uploaded, or any CID of any NFT that has been uploaded to nft.storage. Then you use a GET request to check / and then the actual CID. And so the upload endpoint, you'll need an API key to access. You can upload a single file or multiple files, like using a multi-part request. And what nft.storage does is it gives you back a CID. So it will take that content, it will chunk it up into a DAG, a directed acyclic graph, and this is how IPFS stores files. So it'll create a graph for you and then give you back the CID of the root node of that graph. The check endpoint is not authenticated. So it means that you can do stuff like just paste in, like use it in a URL bar in your browser and get information like this. So you can see the kind of information that you get back. So you can you see the size of the NFT, the pin status, like Filecoin deals that it's currently in, like including like the ID of the miner, the deal ID that you can go and look on chain and say, give me the information for this particular deal, so you can get hold of it and verify that the content here is correct, and the status of that deal. When you upload stuff initially, you'll get like you have queued deals, and they'll eventually make it into a deal, because what we do is we kind of aggregate content together into big chunk, so we can make a big deal with a miner with lots of data. And then that's where this data model selector thing comes in. So you can actually retrieve your particular data from that bigger kind of batch of data that has been put in a Filecoin deal. Cool. Okay. We have an official client in JS. I'm going to do some demos today with the JS client. It has TypeScript types, so it's nice in your editor. It has nice API docs. We've also just launched a new metadata API. I'll show you that in a minute. But what it should do is it should make minting NFTs even easier. You basically specify the metadata JSON content, but where you've got, like you can see in the example there, where you've got properties that would usually be like URLs to other IPFS assets, you can actually just use like files, and what will happen is the client will magically transform those files into IPFS URLs for you. So it should be really easy to create like ERC 721 or 1155 compatible NFT metadata. Later, we'll hopefully be able to introduce wallet auth, so the NFTs can truly be stored by content creators and not just by marketplaces on behalf of them, or nft.storage on behalf of them. Because of the open API schema, you should just be able to generate a client in any language. It's another cool thing about the open API schema. So we did that because we thought, why give people the ability? Why not just do it for them? And so we don't know exactly how many people are using these or if anyone's using them yet. So your mileage may vary. It might be a little clunky because a machine made it, not a human, not like the JS client, which was handcrafted with love. But these other ones, if you have any problems with them, just open an issue or a pull request or whatever. Let us know how you get on with them, and we'll get them fixed or make them better in some way. It would be cool to know if anyone is using them. That would be awesome. Okay, let's do a demo. I'm going to just stop sharing so that I can start sharing my whole screen. Here we go. There we go. Okay. Okay. So, like I said, I'm going to be just demoing the JS client today. First of all, I'm going to show you how to store a directory of files in nft.storage. Quite often, your NFTs nowadays like have like an animation thing as well as a the main NFT asset. So you'll kind of probably want to use store directory. Possibly you might want to use the metadata API, but you could choose for yourself. It's there for you. Even if you have one file, you probably want to just use store directory because you get to retain the file name. Then you'll get the CID back of the directory, and then you'll put like the file name on the end of it. Whereas if you store like just a file, you get the CID of the file, but you lose that file name. So if you then like view it on the gateway, then the gateway might not necessarily know how to render that particular file because it doesn't have an extension to go off. Also, if you try and save that to your desktop, then you don't get like a nice file name. You get like a hash, which is not quite as descriptive. So it's best to use store directory. So let me just have a bit of water. Yeah, great. So storing a directory. I've already installed the nft.storage module. It's on npm nft.storage, and we're importing the client, but also a file, which is basically the file API from the web, as you might know it, but so that you can use it in Node.js. So that's kind of cool. Here we're just creating a new instance of our client. We need to pass in a token. So what you need to do is you'll need to head over to nft.storage and log in, and then head over to API keys. I'm going to delete that one and create one for the demo. Let's call it test again. That's fine. Copy that and then head on back to here. We're going to get it from as a token environment variable. Paste it in there and hopefully that will work. I'll delete it afterwards so like you can't use it and stuff. Anyway, storing a directory. What we're going to do is we're going to store two files, and we're going to store pinpy. This is my attempt at a funny joke, because essentially what we're doing is pinning stuff on IPFS. So pinpy. We've also got this nonsense. You are a nonsense one, nonsense monster. So we're going to create an NFT. Well, we're not going to create an NFT. We're going to store some data that you could use as an NFT, perhaps. So we can use client.store directory function here, and you can see we've got nice docs in the editor for it because we took some care. So we need some files here, files, and what I'm going to do is I'm just going to say a new file. File bits. I'm just going to use, so you probably won't use FS like this, or shouldn't use it like this. I'm just going to read this file in like this for now. So this is us reading an existing file, but in the file API, you normally give your file a file name as well, and it gives us a chance to rename it if we want. Have type, specify a MIME type. I don't think we actually need this, but it is a image / JPEG. Great, and we will put that one, but also Also, you are a nonsense. And I'm just going to use nonsense as my file name for this one. So we've got a couple of files here. We just give that to the client.store directory, and that gives us back a promise of a CID. So that's cool. We can just await on that. And then what we'll do is we'll just log out the CID. Yeah. I think that's all I need to do. So node, wait a minute, I'm in the wrong directory. Store directory, node, index, cool. Okay, so that looked like it worked. I've got my IPFS hash here, and I can head back on over to my browser and put that in. And then I should see that it's created a directory for me, and I've got my two files, my pimpy and my nonsense here. So awesome. That's pretty cool. There we go. So that's storing directories. Pretty cool. But like I said, that's fun because you've now got like a directory of those two things. But when you're minting an NFT, you typically want like a metadata.json file, and then and from that metadata.json file, you'll typically link to other resources that you've already uploaded. So you might have like essentially two calls to the client, one to store the assets and one to create the metadata.json file that links to the assets. So you can do that, that's fine. But what might be easier is you might want to use the metadata API. Store metadata. So let's have a look at this. Starting from pretty much the same slate here. Clear that out. And so with the client, what we're going to do is call client.store. And then we just give it an object here. And this looks like a metadata file that you'd typically see in like an ERC 721 or 1155 contract. So you give it like a name, pimpy, you give it like a description, comic of pimpy, and an image. And this is the cool bit, because what we can do is we can grab our file from here and put it directly in this part. And you can put multiple assets in here, but what will happen is this will give you back the CID. So no, it won't give you the CID. It will give you a metadata object where you can obtain the CID for that metadata.json file that it creates. And then you can look at these, and what it will do is it will take this object, it will automatically upload this file for you, get the CID back, and transform it into an IPFS ://CID URL automatically for you. So so once we've done that, meet data, metadata, all right. Yeah, well, let's just log out. Console.log, so metadata. I'm going to do it again. Metadata, so we've got a few cool properties on here. We can get the data, and that will give you back an object that's basically the same as that, but it's got these file objects transformed into URLs. There's IPNFT, which is a CID of the root, the metadata JSON file. It's also got URL, and this is kind of the thing. Metadata.url is the thing you want to use in your NFT. This is the thing you want to link to the metadata.json file in your token URI, for example. So let's just quickly run this and see what happens. So node index. Cool. Okay, so you can see what it's down here. We've got like our metadata JSON file. We've got the CID. We can take that and then head on over to our browser again. Oh, okay. Great. Let's try it. No. Okay, that's really odd. Let's try logging out metadata.data, and then you can see what I was trying to show you at least. So let's hopefully upload everything again, and you can see here that we've actually got an object, and this is what you would have seen at the gateway, and for some reason it's not loading. But you can see that we've got here our image. Our image property is actually it's not a file, it's now a URL object, and this is the URL that it's created for you. So that's super cool. All right, let's just see if that loaded. Okay, that's really odd. All right, never mind, onwards. So let me stop sharing for a moment. And I will share just my slides again if I can find them. There we are. Okay, here we go. Okay, so far what we've been doing is uploading data and getting back a CID from nft.storage. And what nft.storage is doing is it's doing the work of generating that CID from the data. So it's getting the data, it's creating this DAG, this directed acyclic graph, and it's giving you back the CID of the root node of that graph. So there's a couple of problems with that. Firstly, we have to trust that nft.storage is doing the right thing and actually giving us back the CID, the right CID for that data, and not giving us back a CID for some completely random like spyware and malware. It wouldn't be doing that, but you never know. Secondly, we have to wait for all of that data to be uploaded before we get a CID. Why is that a problem? Well, you kind of need the CID to be able to mint an NFT on the Ethereum blockchain, because you need that token URI to come back with a URL to IPFS content that has that CID in it. So there's a kind of ordering problem there. And for big files, if you've got like a really big NFT, like video stuff, or maybe you've got like game data that is actually a huge set of animations and stuff, then it could take a long time to upload that data to nft.storage. And you've waited that whole time to do that, and then you need to do some minting on the Ethereum chain. So it's kind of like partly a trust issue and partly like a user experience issue. So why can't I just like generate the CID before I upload the data and do these tasks in parallel? Well, now you can, hooray! So storing cars, you can do that on nft.storage now. Cars are not automobiles in this world anymore. They are content addressable archives, and it's kind of like tar, but for DAGs. DAGs being directed acyclic graphs, like I said. Yeah, tar for DAGs, rad. And anyway, that allows you to know the CID before you actually upload the content. What happens is that in the client, we do the work to generate the CID. And that means assembling the data into that graph. And then what we do is we pack that data into a car file and send the car file instead. And what that means is that you can chunk up cars into smaller chunks and send partial DAGs. So each car file will have a sliver of the actual graph that is smaller than the whole thing. And that means you can send data that is more than 100 meg in size. We have a 100 meg limit for regular uploads, but if you upload cars and split them and have them split, they'll be, if you use the client, they'll be split automatically. We'll see that in a second. but it means that you can upload data that is more than 100 megabytes in size. So that's very cool. 100 megabytes, by the way, is we happen to be hosting stuff on Cloudflare, and they have like a 100 megabyte limit for uploads. Anyway, this is how we get around that. But what you might see, this is a completely contrived example, is that this is a graph that your data might generate. We have a root node and then other nodes, and right at the bottom of the leaf nodes where the data actually resides. But in the first car, maybe you've got this sliver of the graph. In the second car, you might have this sliver, and in the third car, you might have this one. And you see that all of these cars actually share the same root CID. So that's how we know that the content is all related, because they all are referencing the same root. So that's pretty cool. The other cool thing about chunking or splitting cars is that it allows for like failure and retry. So if a particular chunk doesn't make it for whatever reason, it gets stopped on the way, then you can resend it. You don't have to re-upload the whole thing. If you've got like a gigabyte of NFT that you're uploading, then you can, and you fail on like a 10 meg chunk, because we split them by 10 meg chunks, you can retry that particular chunk. And also, you can parallelize those chunks, so you can send multiple at the same time. We'll probably see that as well in a second. The other thing is that it allows us to report on progress. So we know when we've got chunks that we've split into 10 megs, we know when each one has finished uploading. So we can say, we've got like a callback where it says like a chunk has been uploaded, and it takes the size, it knows the size of the chunk. So it can tell you, you can report back to users and say, okay, this one's finished. We are making progress, rather than waiting for your gigabytes of NFT to continue uploading. So, all right. Here, let's try the storing car demo. There we go. Here we go. Let's see. Did that eventually? That was Pirate Pro. Okay, here we go. Store car demo. Let's clear this out. Let's close these up. Open up the storing car demo stuff. Code. So basically the same. We have an extra dependency. We have a IPFS car dependency, and what this does is it is the thing that makes a DAG and packs it into a car. So we're using pack to. There's various different ways of using this. Today I've just used the way that is the least code, but what this will end up doing is buffering everything into memory. And if you've got a really large car, you maybe don't want to do that. There's different ways of doing that. You can write the car to disk and then stream it off disk. That's fine also. But yeah, there's examples in the repo of using IPFS car in Node.js. There's also an example in the browser as well, which will be similar to this. But we create our client as we did before. And packing to blob we'll pack some data. We've got our input here, and it will give us back a blob, a car, and also the root CID. So this is the CID of the root, and so we're doing this before we've called any client function to upload the data. And so what we'll do here is we're going to fill this out a little bit. The path is the path that I want to see in the directory that it creates. And what I've got here is, you probably don't want to see this, but this is my skate movie, but I'm not going to show you. It's small. It's only 24 megs. So I'm not sure how this is going to work with Zoom as well, if it's going to take a long time. I chose something really small. But it chunks into 10 meg chunks. So what I'm expecting to see is like 3 cars, one of about 4 meg and 2 of 10 meg. And what will happen is, I think our concurrency level is set to like 3 as well, just to not starve off browser requests, because it can only do like maximum 5. Yeah, so what I'm expecting to see is like it will upload basically all of them at once. The 4 meg chunk will probably finish first, and then the other 2 10 meg chunks afterwards. So I'm going to call this skate movie MP4, like the file. And the content, I'm just going to use fs.create read stream. And there we go. And that's my skate movie. And what we can do is before anything's happened, we'll just log out what our like expected CID we're expecting to get from nft.storage is. So let's log out that root CID. So that's cool. So we'll get that log line before anything has happened. And then we call client dot, we've got a new method called store car. And you can give that like a blob like we're doing here, but you can also give it a car reader. And this is, like I said, if you've got, if you've got like a car that's on disk, you can create an indexed car reader. So you don't have to read the whole thing into memory, but you can also read it into memory and create a car reader and give it a car reader if you really want. But so we're going to give it this blob that we've already got here. And we're going to use the, this is completely optional, but we have an on stored chunk callback. And that gets a size, a number. So this is the size of the chunk that was uploaded, that's finished, it's done. It's already been stored. And then what we'll do is we'll just log out. Stored chunk of size bytes. There we go. So we should see like some log lines saying that cars have been stored. We need to await on this because it returns a promise, and this will give us back a CID, and then right at the end, console.log, the CID. So this is the return CID, the CID we got back from nft.storage, and because we're uploading like a DAG essentially, we expect that CID to be exactly the same as the one we created client side, and you can. In your code, you can verify that the two match up, and no funny business is going on. There we are. Store car, you can give it a big file, blah, blah, blah. There we are, pack to blob. All done. There's not really much here. And obviously input, you can see we've got one file here. You can have multiple files. It puts them in a directory. There's not a lot to it. But so let's see how this works out. Node index. Here we go. So there, that expected CID has come straight away, and then eventually, okay, I've never done this over Zoom, so this might take a while. I don't even know. Hey, there we go. So this is the 4 meg chunk that I said was going to come out first. Then we got the 2 10 meg. So these all went at the same time. They were done in parallel. But we saw the 4 meg chunk come first because there was less data to send. But it really doesn't matter in the order in which they arrive to the service because they have the same route. It doesn't matter that there's one side of the graph has been populated and not the others yet. They will eventually all get, the tree will be completed eventually. And then we got a return CID, which is the same CID as we expected. So hooray, it works. All right, that's pretty cool. If the gateway is working for me, there's a chance I might be able to look at this. But disappointingly not. Okay. That's a real shame. Okay, anyway, I wouldn't normally expect that, and I don't know why that might be. Gateway, the IPFS gateway is extremely busy, and relying on it for production purposes is not necessarily the best idea, or in demos, as you see. Right. Let's get back to the slides. I think I'm nearly done. Okay, so that was the demo. All right, so what is the challenge? If you've been paying attention at all, yeah, or you've probably read this already, but the challenge is to build a game or an app and use NFT.storage, put stuff on there, create an NFT and link to data that has been added to NFT.storage, and hopefully it will be good for you. It's hopefully really simple. Hopefully I've made it a little bit easier for to get up to speed with this. It should be easy. If it's not easy and you're finding it difficult for whatever reason, then please open an issue on the repo, because we would like to know. Resources. So there are a whole bunch of resources I think already listed. These might already be there or not, but on docs.ipfso there's a great how to totally start with this, like best practices for storing NFT data in IPFS. Really good kind of primer on how base level stuff, but definitely start there. And then there's also a good how to on minting NFTs, actually getting them stored on chain, which is a whole separate world. I've kind of described how you might store data that NFTs would point to in IPFS and Filecoin, and all of the history and knowledge about that. But actually, minting stuff is a much bigger process of creating a contract, putting it on the Ethereum blockchain, minting tokens, and it's not nearly as easy as this. There's nft.school.dev. This is brand new. I probably shouldn't be telling you about this, but it's because it's not finished. There's a whole bunch of to-dos and work in progress part there, but there is a lot of awesome content on there already as well. So you should go check it out as well. It's not finished, but it has got some good resources. So have a look at that. There's step-by-step tutorials, how-tos and code samples and references for schemas, and stuff like that. How what DApps are and anything you need to know. But yeah, the tutorials there use nft.storage, so they'll help you. And I think that's it. Thank you very much for listening to me ramble on. I'm sorry the demo gods didn't work out today for me. And happy hacking and creating. I hope you do some good. I'm looking forward to seeing some awesome things.
Yeah, thank you so much, Alan. Really appreciate great workshop. Fantastic, very entertaining also. I loved how you did it, right?
I did this immediately before the workshop and everything worked. So
fantastic. Almost everything.
What can you do? Yeah, the gateway is not always working for you.
Yeah.
They have a lot of traffic and yeah.
Just showcase
sometimes.
That's all good. We do got a few questions, during this session. So we noted them down. Let me just share the screen with you real quick, and then we can just read them from the top. Can you see this? Google Sheet we had created. Yes. A few questions actually got answered by your colleagues in the chat, which is perfect.
Okay.
And so maybe we start from the top and go all the way to the bottom. I think it's minus the ones that were answered. 8 questions. Okay. First question is coming from Manasi. I hope I pronounced it correctly. Can we use VS Code for the algorithm building?
I'm not sure how to answer that. I'm not sure I understand the question, to be honest.
Maybe we give Manasi a chance to rewrite the question and go to the next one. Okay. Do you have a list of games using IPFS? I think Sen probably already showed, right?
I don't have a list of games using IPFS, but that sandbox one is definitely using IPFS. I've seen some awesome games though. There's loads of the Pokemon style stuff, card games. I don't it's not always easy to tell which games are actually using IPFS, because they'll often abstract away all of the you saw in Sandbox, there's just this tiny link to a token URI. You have to kind of really delve to know that they are using OpenSea, and I know that OpenSea use IPFS for a whole bunch of stuff, and nft.storage. So yeah, it's not always easy to know exactly.
Absolutely. Yeah. So for other, I guess, just, take a look at a sandbox game, right? It almost became a sponsor at the Hackathon as well.
Yeah. Anything, basically anything
it,
that's using OpenSea. Like OpenSea is a big marketplace. A lot of stuff is on there. Anything that's using OpenSea probably will be. But yeah, the other I know of a whole bunch of like art NFT marketplaces that are using IPFS, but like yeah, it's hard. It's kind of sometimes hard to tell, and even on those ones, it's not necessarily obvious.
Absolutely. I think the infrastructure is being developed, right? That you get the browser extensions that allow you to, kind of easily check which games or, which NFTs are actually on IPFS, right? Which is informative, right? Just
yeah, we wanted to create and there's already like Check My NFT service. It's like a website for that. We wanted to create one for like a bit more like Filecoin and IPFS orientated. So like how like permanent is this NFT, or how like is it stored well, as in like how many IPFS nodes are currently providing this content, and like is it any Filecoin deals, and just be able to check CIDs. So yeah, if you can get hold of if you can get into the contract, like query the token URI, and you see like an IPFS CID in there, then we wanted to be able to put that into that check website and be able to know, how well stored is this thing? Is it going to stick around for the long haul, as it were?
Absolutely. So if you find something, we will share it with you guys on Slack and Discord. Coming to the next question from VDK. Will the miner store the complete file? I guess.
Will the miner store the complete file? Yes. Yeah, absolutely.
Easy. All right. Then we have one more question from other. Still not clear why I should use IPFS Filecoin. Any reason to use Filecoin here?
So,
understand that correctly.
Like I said, they're both ways of storing files, decentralized, immutable, so it can't be changed. You always know that CID is going to be pointing to a particular piece of content. Filecoin and IPFS, essentially very similar technologies, and they provide redundancy, a whole lot of redundancy for your data. So you know that NFTs are not going to just disappear into the ether. So that's essentially why we're using both. Like IPFS is for like quick and fast retrieval, Filecoin for like long-term storage that's always going to be available, because there are miners with heavy incentives to keep storing files.
How long would that usually be for Filecoin?
I can't remember like the maximum deal terms, but like I think we have deals that last for at least a year.
Okay, nice.
But with nft.storage, we renew deals. Like when they come up for renewal, they'll get renewed. So the content will still be in deals, maybe not the same deal, but it will still be stored when that time comes, which is for all of the content so far, not for a long time yet.
Yeah, exactly. I don't know. It's,
and also, it will always be available in Filecoin. It will always be pinned somewhere that's publicly available.
Absolutely right. Like, have to wait and see how things will turn out. Coming to the next question from Gavine. I hope that's pronounced correctly as well. Would this be good replacement for Textile and Filecoin backup? So.
If you're looking to store like any files, then you can use Textile. If you're looking to store NFTs, then this is a good solution for you. I think actually we're like behind the scenes that we're backing up to. We're also backing up to make sure that we never lose content to some of these third-party services as well. Like we're pretty serious about not losing NFTs. So if you're storing NFT data in Textile, then yeah, you could use nft.storage. But equally, Textile are going to do a pretty good job as well at storing your data. they they exist for that. And Textile offer a whole bunch of other things that we don't have, like that Textile's buckets are super powerful, that we NFT.storage just doesn't have that concept yet. So yeah, you could do, but also like you got to think about like what your use cases are.
Absolutely, thanks for that. Then we come to the next question from Memo. Are you running a node at the moment at your local? I think that was when you were showcasing us.
No, I wasn't actually. Just in case I get just in case, like I don't know, I try to run like as few network services as possible whilst I'm demoing and zooming at the same time, for the good of my. But maybe I should have done, and everything would have worked. But yeah, that's yeah. I don't know. I like the danger aspect.
Next one. Would PowerGate be faster when NFT storage? Sure.
I can't say. I'm not. I don't know. I haven't done any measurements towards that.
Okay. Can't say. Sorry, Guawi. Next one. How much interactive it is something to take on count. Okay. Not sure I know what what that means. I don't know. Can you make sense of that?
Take on count. No. The only thing I can think about is just the progress reporting on like uploading large files. We still because of that callback that I demoed, you can provide feedback to the user so that they do. It's kind of interactive in that way.
I think he just wrote in the chat what he meant.
Okay.
Okay, and Discordian already answered, so we're covered. Okay. Thanks, Discordian. You're super. Next one, Naveen. Where is the NFT storage service deployed? Is it decentralized? Yes, it is. I think it's relatively easy to answer. Next one, can I use everything from front end, like uploading data to IPFS without using server?
Can I use like uploading data to IPFS without using server? Yeah. So you can, we do, so there's something that we call the pinning service API that the nft.storage does expose, and you can add nft.storage as a pinning service, to IPFS, and then you can tell IPFS to pin a particular file, and it will go up to nft.storage. nft.storage will put it on its nodes, put it on Filecoin. So yes, you can. Yeah, in something to bear in mind is that we're thinking about making that like a kind of a like, please get in contact with us if you'd like this API, because we've seen a lot of abuse on that front, because it's so easy to just get data in, and the service is for NFTs, and if people are putting things that aren't NFTs in there, then that's not fun. So yeah, but at the moment, yeah, you can just add it as a remote pinning service. If you look on the website, if you scroll down there's like information about the different ways you can use it. Like you can use it through the JS client, the HTTP API, but also pinning service API. If you can take a look there and do that. I hope that answers the question.
Yeah. Going to the next one, can I use the IPFS to simply chunk the data and share the CID to POP who need the file? Is it best practice? From Vignesh.
So yeah, you did see the POP who need the file. I'm not sure I understand the POP who need the file part.
Vignesh, if you could maybe elaborate on your question in the chat. I'm not sure if you're still around. That would help us to understand it better. We go to the next one and I'll come back to yours later. Next one from Naveen. How is it free to store data using NFT storage APIs? How does the incentive model work? Good question.
This is a good question. Protocol Labs believes that NFTs are important data for humanity, and we want to keep them alive and stored on in the world for as long as possible. It's something that at the moment we're willing to absorb and are are going to keep free for as long as possible.
Absolutely. So it's subsidized by Protocol Labs, right? Protocol Labs.
You got to think about, like, a lot of NFTs are kind of it's like storing art. I mean, imagine if you had, you know, some famous works of art in the world, but we're actually NFTs. It's the digital equivalent, essentially, and we want to keep them alive, and we don't want things to just disappear. And we've seen, like, I've seen people tweeting saying, "I've lost my NFT, it's gone." Like, this URL is, and we don't want that. We're actually starting an initiative. I cut this out because I thought it would be too long, but we're going to be like reading the Ethereum chain from Genesis and extracting all of the NFTs that have ever been created and storing them on nft.storage, so that they don't just disappear. So anything that's already there, we're going to try and back up as well, essentially. That's
pretty cool.
And even the things that are on URLs that aren't IPFS links, so the things that are like on drives or something, we'll try and also download them wherever they currently are, store that, so that even if that thing goes down, then we might still have a copy of it eventually. So that's the plan. We want to save the NFTs.
Oh, the NFT savers should have called it Save the NFT Hackathon. Fantastic. Nice. I think the next question was answered as well. And then we have one last question here from Shraddha. What makes an image uploaded on IPFS and NFT?
I guess it becomes an NFT at the point that you create a metadata JSON file that references that particular image, and you mint an NFT on the Ethereum blockchain. That's the point at which it's like it's an NFT, because it's now provably been created by someone.
Exactly. So the IPFS provides you with the image, which is then the metadata that you put into your NFT file, right? Into your ERC-721 or 1115. Great. So I think there was this Colin answered the last question, and I think we are good to go. Fantastic. Thank you so much, Alan. A great workshop. Very entertaining.
Thank you.
Love to have you here. We have recorded the session, so we put it on Slack and on Discord in the days to come, probably on Wednesday or so. And there's one more workshop tomorrow night for all of those of you who are interested. It's for the scalable NFT art project track by Endorse. So it's also 1 p.m. UTC, same time like today. So, be there, be square. Looking forward to see you there as well. And then happy hacking. I think Alan and the Protocol Labs IPFS Filecoin team, they are on Discord and Slack. So if you have any questions, please shoot them over there. Make sure to answer as many as possible. And also reach out to myself or the other NFT Vision Hack admins on Slack or Discord. We like to create those private groups with you, where we kind of introduce you to the right mentors, where we give you feedback and guidance on your project to increase your chances of, winning something from this hackathon, right? So really use that chance, ping us on Discord, ping us on Slack, and, we'll be there to assist you. We create those private groups with you and, give you feedback and everything. And, also introduce great mentors, like Alan and others into those groups to kind of, answer, the very technical questions that you may have. Perfect. I want everyone to thank you for attending tonight. And then I see you all again, hopefully tomorrow. Bye-bye.